Hello Year 7. Today we're doing atoms, but before I start I'm going to go back into my lesson 1 folder. I'm going to open this table and then I'm going to go to view, rotate clockwise. I'm going to keep this to one side because this is going to be useful for today, so we'll keep that out of the way for now. What I might actually do as well, I'm going to copy this just for everybody and have it here because it's really useful. So today's lesson, atoms. Right. Now, which of these show an element? Hopefully. Well, I'll let you pause it now, have a think. I think most of you got the right idea. And the right answer would be this one. Why? Well, it only contains one type of atom. This specifically is an alloy. This is a metal mixed with something, two different metals mixed together. So that is a mixture. But this is an element. So I'll let you pause to read these, but I'm just going to brush past them because I'm going to talk about what we're doing. We know that everything's made of atoms. We've done this before. And we know that that's the definition of an atom. So this is kind of like a recap of last lesson. So we'll go back to here. We should remember that copper, carbon and helium are all elements, and you can see they're all made of one type of atom. Now, one atom on its own does not have the properties of an element. A gold atom is not yellow, it is not shiny, it is not solid, liquid or gas, and an atom of gold cannot melt. So, why is this the case? Well, if you go down to an atomic level, all of the properties sort of don't really exist. If I have a single atom, it is just an atom. It can't have a colour. It's too small. And we talk about wavelength and how we see things in later topics. So for now, you're just going to have to trust me a little bit. But the reason why things have properties is because billions and trillions of atoms all together have certain properties. It's how they bond together. That is what gives them the properties. If there is no atoms bonded to anything, it can't have a property. No. So here. Hopefully we've heard of steel before. The UK used to have a very big steelworks. And steel is iron mixed with carbon. The reason why? Iron by itself, if I go back, notice that here, instead of gold, just imagine this is iron. Nice, neat rows. Okay, it makes it quite soft for a metal, so you can bend it, you can mold it into shape, you can hammer it around. It will bend, it won't break. But if you put little bits of carbon in, so you mix it with certain amounts of carbon, notice that the nice neat structure here has been disrupted. It's no longer neat. That means that this line cannot slide past anymore. So before, on the other one where it was nice and neat and in rows, the lines of atoms could slide past each other. That's why iron is malleable and why you can bend it and hammer it. Now this will not happen. So making an alloy, makes the iron, in this case it's steel, much harder, but it becomes more brittle. You can't get these lines to slide past each other, so they would break. We use steel to build bridges with because it's extremely hard, so it's still very useful. So let's have a look now. This is the important part of the lesson. Structure of the atom. Now, if you're going to take one thing away from this lesson, it's this table. You need to know this. One thing I will say is just remember the relative mass of an electron is 0. It's not. That's why we've got that there. But just remember the relative mass of an electron is 0. So let's have a look. Proton, neutron, electron. These are the 3 subatomic particles you need to learn. These are their names. A proton has a relative mass of 1 and a relative charge of +1. It is a positive charge. Now, the reason why we call it relative mass and relative charge is because we are comparing these to each other. Actually, these are tiny. The numbers are so small, they will be hard to read. You haven't done standard form yet, but this would be like 0.00000000000, and it would go on for a while, and they would have a mass. So that number is so small, it's not useful to us. So that's why we talk about relative mass, because the proton, relative to the neutron and the electron, it's easy. A proton and a neutron are the same mass relative to each other because they've got a 1. The proton and the neutron relative to each other have different charges. The proton has a charge of +1. The neutron has a charge of 0, which is neutral. And the electron has a relative charge of -1. That means the charge is the same size as the proton, but it's opposite. Okay? Now the relative mass, the proton and the neutron is the same, and the electron, we can kind of say that the mass is 0. It's not exactly 0, but let's just leave it at that. Let's look at this. There's helium. Here are the important bits. So if we look, helium, the symbol is there, He. 4 is the mass number. 2 is the atomic number. And when I go back to my periodic table in a minute, you'll see that the key says the same things. Now, the important bit to take away from this is the number. The numbers. We need to know what they mean, and we need to know how to work certain things out. So if you look, the atomic number is the number of protons. I'll start that again. Every atom of helium will only have 2 protons. An atom is defined by the number of protons it has. So if you find something and it's got 2 protons, it will always be helium. Now, this number can change. Okay, this number can change. You'll be different as long as you've got 2 protons, you are helium. So this tells you how many protons you have. It is the proton number or the atomic number. The top number is the mass number. Now, if you look on the table above, only 2 of these objects have mass, the proton and the neutron. So this mass number tells you how many protons plus neutrons you've got, because electrons don't have a mass. Now, because you know that there are 2 protons, you can figure out how many neutrons are there. Now, I'm going to go on to the next slide just to sort of illustrate this a little bit better. Notice your electrons here around the outside orbiting the nucleus have a 0 mass, and everything in the center, and that center bit we call the nucleus, has a mass. And you only have the protons and the neutrons in the center. Now I'm going to exit this PowerPoint. Okay, we're going to minimize. Here's my periodic table of the elements. I'm just going to open. Okay. Now, I'm going to pick an element here. So let's have a little look. I like lithium. Lithium's a good one. So there it is. You see lithium just here. I'm going to get my pen out now. Change my color to, we'll do red. Right, so lithium looks a bit like this. There's lithium. It's got a 7 above. It's got a 3 below. It's got the writing there, and it's in a little box. So remember, if I go over here, zoom out 1, it tells me everything. So this top number from the key, it says that this is the relative atomic mass. Okay, Then I've got the atomic symbol, then I've got the name, which I've ignored, and then I've got the atomic or proton number. I'm just going to write the proton number. Okay. NO dot is just shorthand for number. Now, what I want to do, because I told you there are 3 different subatomic particles that we need to learn, you're going to write pen down your page. I always write it like this because 1, it's easy to remember, just pen, and 2, it helps you get the numbers correct. So P, remember, is for proton, E is for electron, and N is for neutron. So how many protons, electrons, and neutrons do we have? Let's go. Well, oh, that was unexpected. Let's make my brush size that. Okay. So that's my proton number. So that's telling me I have got 3 protons. Now what I'm going to tell you now is that the number of protons and the number of electrons are equal in atoms. So another reason why we write it as pen is because these 2 are going to have the same number. So if I have 3 protons, I will have 3 electrons. Now, the relative atomic mass is the number of protons plus the number of neutrons. Okay. In this atom, the atom has a mass of 7. One lithium atom has a mass of 7. And we know the only 2 things that have a mass, are the proton, which has a mass of 1, and the neutron, which has a mass of 1. Okay? So, if I have got 7 things in total, but I know that 3 of them are protons, that means I can't have 7 neutrons. I must have 4 neutrons. And let's check. Well, if 1 neutron has a mass of 1, 4 neutrons has a mass of 4, 3 protons has a mass of 3, 4 plus 3 equals 7, so we know we're correct. What I'm going to do now, though, is I'm going to draw it out. So we'll do protons red. Do you know what? We'll start off. The mass, the relative atomic mass. We know there are 7 things inside the nucleus. So let's draw the nucleus with an imaginary green dotted line. The nucleus doesn't have a boundary. It's more just where the particles exist. So we can draw a line there if it helps. So I've got 7. So 1, 2, 3, 4, 5, 6, 7. There's my nucleus. We know that we have 3 protons. And we know protons are a positive charge. So I'm going to put, for now, I'm just going to put a P inside 3 of them. P, P, P. There's my 3 protons. And we can see that I'm left over with 4 neutrons. So I've drawn the center of this atom, just like I did, just like on this diagram here. I'm drawing this atom. Now, the last thing that's left is to do the electron shells. So I'm just going to show you this now. This is a bit above what we need to learn. The electrons, we've already said there are 3 of them. Okay, so 1, 2, 3, and there we're done. Now, what I need you to do what I need you to do now is go onto this worksheet here, and you can see everything that we've talked about is there. Now, I've gone a little bit above what we need to know, talking about the structure of the atom and how to draw an atom, but I think it will help a lot. If you get stuck on this first section with the filling in the blanks, just leave it out. It's not the most important bit. The most important bit is the names, okay? And I've already said, sorry, this one here, just so that you don't get stuck. These lines going around the outside are called electron shells. Okay, so this is called an electron shell. Now, you should be able to now fill in all of these labels. Okay, you know that the nucleus is the bit in the middle. You know the subatomic particles. You know the electron shells. Now here is the names. You need to know the relative masses and charges, and then on the next page, this is what I've just taught you there on this blackboard. You need to go down your periodic table, find the element. So if it's easier for you, maybe you could go down and find all the elements' names first. Then you need to use your shorthand, this here, using the periodic table. Tell me what number of protons, electrons, and neutrons are there. And as a hint, this number and this number will be the same. So have a go at that. Try and fill in that form, the worksheet, and email it back to me, please.